Okay, my friends, they finally acknowledged my research. They're saying new physics searches with single electromagnetic shower events, which I show at Fermilab short baseline neutrino program. Fermilab is the one that stood in the way of all this. They're saying right here, the observation of sterile neutrinos would provide physics beyond the standard model, as well as being a vital component in understanding the mass generation mechanism for neutrinos, which leads to free energy. This just came out in June 2023. They've been following my work. I know they have, because I've been interacting with Fermilab, and they have shut this down until it's become no longer possible to hide from the truth. So don't forget, this just came out June 2023. The observation of sterile neutrinos provide physics beyond the standard model. We did it. Okay, so the standard model changes if I can separate these two, which is the muon neutrino and electron neutrino. They're called diaracs, and they normally look like this. And then when they separate, which nobody else can do, they actually turn into the muon neutrino and the electron neutrino in sterile form. Individual neutrinos changes everything about the standard model. We accelerated light, we split the black from the white, which is the muon and electron neutrinos, so we have sterile neutrinos. That's fission, that's fusion. There's a lot of changes right here just in this one picture. So let's get deep into this, because I have all the evidence to support every word I'm saying. We changed the atomic model 100%. And we have all those spinny little particles they're talking about, the little Twitter. I think I started out by talking about that, or I will shortly. These are the particles that they're talking about, little Twizzlers. All right, and I'm going to go through all this stuff, so get ready. All right, CMOS is what you need to sense individual light photons. They just picked up on this recently, because what they were trying to look at was big particles which are huge, and they damage the CMOS. But CERN did go and change their CMOS to harden it, and now they're using that as well, I believe. Now, this was what we used back in 2014, 2015. Samsung Galaxy S3 phone. That's it. And Rod used the selfie side, put it right up, and took all these pictures that I'm showing you, all of these pictures were done with, well, not every one of them, but almost every one of them was done with Rod's phone. And he said it was the best. And the pictures, look at this. This is Higgs fields on steroids. That's that white coming through, which is the electron showers. Enormous amount of energy, creating Higgs fields. And he was putting this right up in there. Boom. Taking the selfie side. And it has more of a concentrated package of pixels appears, because he said that was the best he had found and the best phone he had found. And they all use CMOS pretty much. I'm sure the newer ones probably work just as well or better. Who knows? I can't see any better that you could do than that. Okay, my outstanding friends, it's Roger once again, Mudfossil University, and if you have been watching me at all, you are certainly familiar with my dipole electron flood theory that says there is nothing but dipoles, and that a proton is not like a ball like that. It is a bunch of dipole magnets, basically, almost identical to this. And they seem to become stable at a certain small quantity which composes a proton. But it's about, I had it calculated at 1837 dipoles. But I think it might be 1823. I'm not sure. It's somewhere in that range. And all it means is every one of these particles has a certain weight. And if you add up a certain number of them, it comes to the mass, which is called 1 atomic mass unit, which is the weight of a proton. So it just consists of a bunch of little particles. Each one of them has a certain weight, and when you add them all together, they equal this. How many there is, I don't know. But you would take 1 divided by whatever the number is, and that number represents 1 dipole electron. And a dipole electron is a dirac neutrino. We're going to get into it right now, so get ready, because we're gonna get into all of this. That's the Dirac neutrino, black and white. I showed this a million times. And we also found that same particle, and here it is right here. All right, and that's the black and whites. Two of them together make a photon. A photon is the smallest unit of mass that is stable. A photon is stable. That will bounce just like a rubber ball bouncing back at you. And the speed and the frequency that it bounces back determines the color and the intensity. This is really quite simple once you understand dipole electron flood theory. So, let's see if we can make that understanding understandable. Okay, my friends, get ready for this, because it is going to be fun for me, for sure. What are we talking about? Trembling along the way electrons. Well, what does that mean? Trembling along the way. They oscillate and spin like unbelievably fast, and they tremble, basically, as you could say. The German word Zitterung, zitter means trembling along the way, and it was coined for the first time by Erwin Schrödinger in 1930 when studying the solution of Dirac equations. Dirac equations, or Dirac neutrinos, are the only things that exist. And we live in a sea. It's called the Dirac Sea. I'm sure you've never heard that before. All right. I've been trying to figure a way to present this so that it's very, very simple. And because I do things simple, the simpler it is, the easier it is to understand. And light spins and it goes forward. That's light. And it consists, 100% of everything that exists is based on the Dirac neutrino. And this is all about the Dirac Sea, which is all the light and everything there is. All the quantum foam is all made of Dirac neutrinos in different states of energy and in different quantities. Dirac neutrinos add together just like this, and by the time you hit about, it's either 1823, between that and 1837, somewhere around there, number of Diracs together, you end up with a proton. But a proton is really solid. It holds together very well, because at that particular stage of particles, there's some frequency that exists in the universe, apparently, that locks them in at that frequency. And then the next time is another 1836 or 37 or whatever it is, and they lock in again and again and again. These are like building blocks. And the more and more you have of them, the bigger and bigger the atomic number is. And the atomic number is the size and the number of protons. And then they throw a bunch of neutrons in because they got nothing to do with it. They're extra, but they just don't understand it. You'll understand it fully with electron flood theory. There is just nothing more than these dipoles. So a neutron and a proton, they're meaningless. A neutron is an even number, which is that stability, an even number. It doesn't want to take another one on or give one up. A proton is just close to that number, but it's one less. So it has a charge that it wants to attract another particle to become a neutron. That's all it is. And that's why it becomes reactive as a atomic particle, like H2O. You got two H's and an O. You want to always get into 8. It gets a little bit complex, but not too hard to understand. Let's look at the physical evidence that proves this is precisely what Dirac was talking about, except they were going by all the rules that were, this Compton's, the Compton and all of the different laws that they came up with. And the speed of light is invariable and all that stuff is all wrong. So they started with the wrong assumptions. So they ended up with the only controversial feature of the equation is that it picks a subatomic particles oscillating at speed of light, of movement that superposes to its transitional motion. So in other words, it can go faster or slower than it's supposed to. No mass could travel at or faster than the speed of light. That's just not true. the physical oscillation of the mass would violate special relativities. Who cares? That's all wrong in the first place. That's the problem. You get into these restrictions that force you to say, oh, hey, we can't even go down that route because it just doesn't work. No, it does work. The other stuff doesn't work. That's the problem. All right, once again, there's all kinds of restrictions and rules and laws, Compton wavelength, Planck constant, Schrodinger equations. But Schrodinger suggested that the electron performed an extremely high frequency circulation motion. All right, so, and then it starts talking about Dirac full relativity and all that stuff. Let's look at the actual physical evidence that supports this high spin. All right, this is the best shot I have. It was done by Rod Warren, and it shows that light is literally spinning very fast. This is blue, and that is a fast spin. And this is done with CMOS. It's fully understood. You can see the photons of light with CMOS. It's not a problem. And it doesn't interfere with anything, because all we are doing is picking up the radiation way out here. All right, other things invade it with light and charge coupled devices and so forth. Then you get the observer effect, because every time we look at it, it changes. No, if you look at it from out here, it doesn't change. And only if you add something to it, it changes, or change the magnetic signature. That's what they're doing by these charge coupled devices. This shows light spinning like crazy, and it's spinning to the right, which means the particle is drifting to the left. Also, I can show that this is light accelerated, and this is light slowing down. Light speeds up and slows down. All of these restrictions that were put on the people doing these experiments and so forth, they destroyed all of their research, because they were forced to say, well, that can't work because Einstein said light doesn't change in speed. Well, it obviously changes. This is light just starting to accelerate towards our Venturi. It's pushing against all the other magnetic particles fields that are in the air. You have a 21 centimeter line around hydrogen. So you have a smaller line around a photon, but the photon still has this huge field around it, and it has to concuss everybody else's field. That's the nature of it. Now, this is the speed of it is just starting to accelerate. Here's what happens when it does accelerate. Nobody can tell me that light is not accelerating. That light is accelerating so fast that the particle that has that bubble around it, which makes a wave, is accelerating and pulling itself right out of the bubble, smashing here and creating fission and fusion. And I'll show you the black and white particles divide, and they are the Dirac neutrinos. All right, so don't forget, these are the Dirac neutrinos. Normally they're black and white, but sometimes they see them in a not quite one way or the other. But they're still the neutrinos, the smallest particles that exist. All right, so this is Fermilab's article about the two particles that I'm showing. That together is a Dirac neutrino. And this one has all the mass, and this one has all the energy, all the burn. Shown this literally hundreds of times, and they say in summary, the extended particle, the black one, has a fixed size, never changes. It may have a fuzzy edge around it, which it does. The point-like particles are the glowy ones, and they say it's a zero size. It's almost zero, but it's not completely zero. But it has an extended field, precisely, a huge extended field. So that's, again, right from Fermilab. Now, they also talk about the Dirac, and they talk about the quantum foam, and they talk about the standard model, saying it's very successful. It is not successful. It does not work. The quantum foam is true. All right, so here's Fermilab, once again, Fermilab, quantum foam. It says empty space is not empty. Empty space isn't empty. It's saturated with these particles. It says it's like the foam on the head of a root beer. It's complicated environment, bubbles appearing and disappearing, dizzying display of change everywhere. Empty space experiences a similar activity. The subatomic, smaller than atoms, these particles here, winking in and out of existence. Light is winking in and out of existence because it's banging into each other. These ephemeral subatomic particles, less than atoms, are real and have a measurable impact on our universe. I agree with that 100%. That's Fermilab. Now, they also wrote about the Dirac neutrinos, and they just don't understand what they're doing. They're looking for this muon, which I can show the muon, and I can show the muon spin, and I did it all without doing all this and all these people. So they're looking a new experiment planned at Fermilab to peer into the subatomic world and to find muons. Now, muons are similar to electrons, 200 times heavier. They claim if you can separate the two particles, you can at least get 200 times more energy. And I found that we can separate them very easily. And then in electron showers, which I will show you, they say it's almost unlimited how much energy you can get out of those. Okay, this is another one about Fermilab's discussion about electromagnetic showers, how they create pairs of photons and then they shower, and they can create enormous amounts of energy. And this is intro to the MU2E tracker, and this is from Fermilab as well. And they talk about all this energy and da 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 da. And they're just missing everything because they don't understand the dipole electron flood theory. You can't get anywhere. It says the calorimeter is a device that measures the energy of a particle by making it shower and measuring the energy in the shower, usually by turning the energy into light, which is what we did. We turned the energy is light to start with, and then we divided it into the muons and the electron neutrino. That's what they wanted to do, was find muons. Okay, this is the Department of Energy, and they're going to explain muons. All right, and they're again talking about Fermilab. It says the muon is one of the fundamental, that means the smallest subatomic particles, the most basic building blocks of the universe, and it is described in the standard model of particle physics. Muons are similar to electrons, but weigh more than 207 times as much. I think that is correct so far. The muon is part of the lepton group. The rest is all nonsense. The only thing that exists is the muon neutrino and the electron neutrino. And they just can't understand that because they want to stay with protons that are just made of quarks and hadrons and all these other nonsense names. But they're not. They're all made of dipole electrons. This dipole electron flood theory is what the core of everything is. And there is nothing that doesn't consist of these Dirac neutrinos. That's all. We live in a Dirac sea. You see this? This is the problem. This has been going on since 1950. They've been looking for these particles. And now they're claiming we found them. Researchers supporting, often in collaboration with scientists around the world. I see no collaboration. They haven't talked to me. Contributed to Nobel Prize winning discoveries and measurements to refine the standard model. If you won't look at the stuff that I'm providing and showing that is actual physical evidence of light, not proton to proton collisions, photon crushing conditions. If they won't look at that, all this stuff is just slapping themselves on their own backs. All right, here's a project that they did. It's called New Physics Searches with Single Electromagnetic Shower Events, single particles, which I am showing, and they're looking at Fermilab's short baseline neutrino program. They still don't have it right whatsoever, and this is just came out, 2023. Now, this is what they're saying. The observation of sterile neutrinos. A sterile neutrino, as I will show you in a minute, we have shown as much as you want to see, I can show you. So the observation of these sterile neutrinos would provide physics beyond the standard model, which I have done, as well as being a vital component in understanding the mass generation mechanism for neutrinos. Because the neutrinos are what we want to generate, because that is what electricity is made out of, is the white part of the neutrinos. I'm going to run through it real quick. Just a standard light just beginning to start to accelerate. That's a pulsed red laser. This is the acceleration phase where it just goes like crazy and starts because of a venturi. A venturi is a very restriction here, and it causes the light to separate. The black stays here and the white goes through a shower. That's the particle. Now, to look at the actual particle itself is there right there. And there's two Dirac neutrinos, one here and one here. And they keep coming across. These are neutrinos that have not developed into photons yet. A neutrino is, it changes flavors, they call it. It gets stronger and stronger. Now, that was the green, the red. Here's the green, the same exact particle. No difference whatsoever. The black and the white. But it's much stronger in energetic value. And these are the spinning particles, and they create these neutrinos, which are not fully formed photons yet. Now this is a muon, and that's the electron neutrino. Muon neutrino, electron neutrino. Together they made the Dirac. And here they are right here. I showed you this very clearly. And this is what they look like in their black and white phase, and this is the colored phase where this is red. Now remember, Fermilab said it would be fixed, the black. Never change the size, ever. You just bash it around as much as you want, it stays the same size. But it has this glow around it, which is this glow right here. I'm showing precisely what they claimed. No difference whatsoever. However, once we put it through our Venturi, all the things changed. It accelerated like crazy, that particle, and broke apart here. And it came back to here. In the middle is electron showers. You see this? This is the muon neutrino, the black one. We turned it into a sterile muon. That is beyond the standard model. We turned the electron neutrino into electron showers. This is from CERN and Fermilab. This is not my doodle here. It says this is what they want to see to break the standard model, and we did it. The muon became sterile, the black one all by itself. The white turned into a shower and went through the Venturi, and then the black reattached here. In this phase right here, we have sterile electron neutrinos, and that is electricity that fills up your battery. It doesn't have any weight to speak of at all. Your battery weighs 10 pounds, and you drive for 100 miles, and when you come back, it's empty with electricity, but it still weighs 10 pounds. That's all you're putting in it is this white stuff. The black stuff has all the weight. And that also is what Fermilab said in their point particle article. Point particle article. I like that. So we showed light accelerates, no question. I showed light slows down, no question. I showed that light can do fission right here. This is fission. That's fission. When you break something apart, it's fission. The black became a sterile muon, and then it came back together over here. That's fusion, fission and fusion. Raw electricity. This is electricity. That's not just raw electron showers, which it is, but it is raw electricity. All we have to do is push that down into a battery, and we would have free energy. And this is how simple it is. Sending a laser to pulse. The black particles can't get through. It just pushes the way through, and it keeps banging them. So they're not coming back out. They're going through, and they have to go somewhere and put them in a battery, and then go drive around all you want. And you could run this 24 hours a day. There's going to be some engineering to do, because Rod Warren did these experiments primarily. I did some of them, and a couple other people did some, but Rod Warren did basically all of them. Let's just go with Rod's work. And it sure shows the black and the white. And the black is dark matter. Nobody ever knew it was there before. They always thought an electron was just this. It would glow and it would burn and it would do all the things electricity does. Nobody knew those two were attached together. And they still don't know it. Because when CERN and Fermilab do their collisions, this is what they see. They don't see it. They have no idea what they're seeing. They dig around in here for years and try to find the smallest little pieces. And we found another lepton. Well, we found a quark. Well, we found a hadron. Well, we found an axion. Well, they got names coming out of your ears. The only thing that exists is the muon electron neutrino, the Diracs. We live in a Dirac sea. Okay, so how can I say we separated the Dirac neutrinos and made them into sterile neutrinos? Which is one black one and one white one. The white goes into showers, the black stays fixed. Here's how I can prove it right here. These are the black and the white or glowy particle. They come green, blue, red, and so forth. Now, The black never changes size. We did this. We created exactly that using light. So now these are the neutrinos. If we could separate those, that means they become sterile neutrinos. The black would go on its own and the white would do something else. In this case, the white went into shower mode. All right, which is exactly what they say from CERN and Fermilab. This is from CERN and Fermilab, not me. This is neutrinos, neutrino. These are muon electron. The electron goes into showers. The white one. The black one never stays just black ball. It never changes size. They add back together here. See, the only reason you can see them is because they're laying on top of the white, so the white is not hitting us. Normally you'd never see that because the black is always behind the white. The only thing we ever see is light bouncing back at us. You're never going to see that. The only way you would ever see that is by doing this. So the only way you can see them is if the black gets on top of the white and obstructs it, because the black does not emit, it doesn't absorb, it doesn't reflect, it doesn't mind being right on top of each other. They don't care about being on top of each other. They just... no problem. These, they hate each other. They hate each other. The white ones cannot get along. That's why they explode here, and they have that huge field surrounding it. Do you know how big the field is surrounding one hydrogen atom? Wait till you see this. It'll blow your mind. All right, this is the wavelength of a hydrogen atom. All right, so a hydrogen atom is the nucleus and one electron, they say. Well, it's not really that way, but let's just go with this. Why 21 centimeters, the magic length for the universe? Photons come in every wavelength. They come very long and very short. Really fast ones are blue and ultraviolets up in that really high energy range. The really slow ones are the red, and the red appear to be the photons that come from hydrogen. All right, so they come in every wavelength you can imagine. Now, one particular quantum transition makes light at precisely 21 centimeters and is magical. You see that? That's 8.2 inches. And that is the frequency. So it goes up like this, it comes down like this, and it comes back up. That's how long one single light wave from a hydrogen is. That's phenomenal. Now, the blue ones are just, but you'd have thousands of them within that 8 inches. You'd have millions of them probably. And the green is you'd have thousands of them, and the red you have one, because it's the smallest particle that exists. So when it gives off an electron, it just sort of floats off of there pretty easy, because it's just a small mass holding on to it. When you get way up into your heavy things, you know, plutonium, uranium, and all that, that's why they're really held tight, and then boom, you got to really blow them up. When you do, they take off and they take chunks with them, and that's what causes a problem. Hydrogen is a whole different story. When you explode hydrogen gas, it breaks down into every single particle. Everyone becomes its own particle. That's why it's such an explosion. Hydrogen gas, you go pow, and it just, every particle goes on its own way, because it becomes completely disassociated, and all the electrons turn into heat or energy or light. Okay, let's just fully understand what the spectrum is. There's frequencies, and they're not flappy little waves that go like this. They're spinning. They look like waves. If you look at them like this, that looks like a wave, yes, but it's not. It's a spinning particle. All right, so it's spinning this way, looking like a wave. It's up and it's down, and it's up and it's down, and it's up and it's down, and you see it as this. Now, what is red? Red is way out this way. See this? This is the infrared and the radio waves, microwaves, infrared. All of that stuff down here is very low energy particles. They're very slow. They're going. Now, as you get higher and higher up in the frequencies, and some of these are not allowed into our atmosphere, penetrates Earth's atmosphere. Microwaves and parts of the infrared, no, absolutely not, because they're damaging, and they get absorbed in the gaseous envelope. However, down here, yes, the heat part, radio waves, parts of microwaves, parts of infrared. Visible light is what we see, and this is right here where all the different colors are. That's the visible light, and we can see that range. Then you get into the ultraviolet. That's where it gets start really getting hot and powerful. And now you're down here where it's spinning like crazy. And when you get down to gamma and X-ray, all you got left is the black part. The white parts are gone. These are just the dense particles, and that's why they cause so much damage, because they're just big blobs of mass. Before that, you have light, which is sort of bounces. That doesn't bounce. That smashes. All right, so don't forget, all the things I'm showing you are based on not this, where you take huge particles and you smash them together and you get all bits and pieces, huge protons. No, what we used was light. So we started down in this range, which is down here. They see these particles. So all we ever see is this, or these little tiny bits. We never see all these big gigantic pieces. X means it could be this big. Could have all those particles. Other ones are just bits and pieces of these. In bigger chunks, smaller chunks, doesn't matter. They call the particles zoo. We started with the photons. I showed you the photons, I'm sure I did. But if I did not, I will right this moment. And here they are. These are the photons. And that's exactly what Fermilab says they're looking for, is these fixed particles, never change. These get glowy and big when they concuss with the particles in front. You see? That one diminishes. And then this one will flip to the back and that one will go to the front. They call it the Muon wobble. And here's what it is. When it's that's what they look like. That's a photon. Now, they really never saw these because they started with all these big chunks, and all they see is debris, literal debris. And then they dig through it, and they see particles like these. And they probably find a lot of them, but there's so much debris that it's just another piece of the chunks of stuff. You see, this is green and red coming through the same venturi at the same time. Don't forget, the venturi is two pins sticking straight up. The light's coming through. You got red at the bottom, you got green above. The green is way more powerful. It concusses way out here. Here, it just pushes the red and makes it roll. That never happens. They always spin like this. They never roll. This is the only time I've ever seen that happen. And that's because this is literally pushing its magnetic particle against this magnetic particle, which is in its straight up configuration, and making it spin. They don't do that. All right, everything I will show you about light shows that it spins in a circle like this. And they're all over the place. There's a bazillion of them. And most of them go through the center. Some of them come back through this way. Some of them come way over this way. Some of them come way over this way. It depends. But this is a drill bit. So it's spinning this direction. All right. And we're seeing it concuss, through the venturi on a back plate, basically. And that's what creates these interference patterns. The interference is because of magnetic push. As they come through here, they want you stay here, you stay here. And they set up these very discrete lines, as you can see. All right, here's another one Rod did. He's got a venturi somewhere right in here and right over here. And the light's coming, and it has to force itself in. When it does, it crushes. It turns very brilliant. And then you can see it spinning to the right. You see it spinning off this way, off this way. So it's spinning this way. I believe that is the last bunch. And we're looking at the back of it. See, we'd be looking at the back of it here because it's already gone. And then there's a stop for a second, and then another pulse comes. And I believe that's the back that we're seeing leaving. This is one coming through the venturi here. That's what it looks like to me. Here's another one. There's a lot to think about here. There's just not a bunch of dots and that's it. You see on the edge here, something's forcing this in, basically, or you're getting a lot of white concussion out here. And the same thing down here, you're getting some serious. In here, they're spread out a little bit. I'm trying to understand why these reactions out here are quite a bit different. And that's coming out of the venturi. So I don't know. I got to look into that. A lot of this nobody's ever going to figure out. I don't know. How the hell are you going to know what that means? But the more white you have, the more interaction you have. That's all I can tell you. White means you're getting more concussion. Anytime you have push to shove, which means a field against another field, you're going to have that glow. So, but you see this here, how it sort of tapers off here, but out here it's powerful, in here it's powerful, I don't know. So don't forget, we live in a Dirac sea, and there's the particles. There they are, right there, there they are. So, this changes everything in physics. The standard model is no more. It's electron dipole flood theory.